students, welcome to the knowledge series on soft computing. Soft computing, as a name, it refers to the collection of a computational technique in computer science, artificial intelligence, machine learning, and many other engineering disciplines to study, model, and analyze a complex task. So as the name soft means it is flexible, and computing means it is producing a output results. So in the soft computing, we approach a very flexible mechanisms. Thereby we can able to get results based on the assumptions. So it basically deals with assumptions. Accuracy is not the main factors. However, it can able to produce the results based on certain tolerance. So that's exactly the soft computing means. Or in another word, an approach to computing parallel the remarkable ability of the human mind to reason and learn in an environment of uncertainty and imprecisions. That means soft computing, when it is producing a approximate results, it tries to see that just like a human being try to learn from the experience, and based on the experience it try to build up its own assumptions and its own decision to predict the output, or it produce the corresponding results. So there will be a human way of interpreting any particular systems or a particular decisions is based on the uncertainty or imprecisions. For example, if when we try to take an example of a room temperature, we never take it into consideration of a room temperature based on the numerical values like a 30.39 degree or 38.17 degree if it is getting hot. Rather we try to take it in considerations based on the assumption that maybe it is above 35 degree or maybe nearly 40 degree. So that based on the uncertainty or the imprecisions, that approach is known as a soft computing approach. You take an example of a soft computing approach by referring to this particular slide, a consumer applications. For example, like a refrigerator, in the case of air conditions, in the case of a fridge, the fridge inside what chillness we need, in the air conditions what temperature we should set so that the room temperature can be made it flexible, or what is the heater temperature, how long the washing machines need to operate. So these type of machines are based on the soft computing techniques, or that's what indicates. The robotic applications, if you look across the pet robots, that is emotional pet robots, the robotic application based on soft computing. Food preparations under the microwave or under the rice cookers, if you look across there, it does not put a word like a degree in terms of a decimals. Rather they will put it in the form of a level, low, medium, high. That is what we term it as a soft computing technique. Or in the gaming product like a checker and a poker, or a recognitions like a face recognitions or a handwriting recognitions. So these are nothing but the areas related to the soft computing. Now let's see further what are the components related to the soft computing. The soft computing components related to the three major contributors. One is fuzzy logic, another is neural network, and the third is evolutionary algorithms, or we can put it as a part of a genetic algorithms. So when we look across the fuzzy logic. As the name of the fuzzy, you can take it in such a way that a fuzzy means vagueness. So it's a technique of a vagueness of any solutions and present that particular solutions in terms of a degree of vagueness. So that degree of vagueness is which is a practical to a human decisions. So we as a human being we term the fuzzy in terms of a degree of vagueness. And actually fuzzy logic, it's a mathematical logic, and it attempts to solve the problem in a imprecise conditions, and there will be an array of imprecise conditions, and later we will use that entire array and try to find the approximate or the closeness value of the desired output. So it is widely used in the artificial intelligence for the reasoning purpose, the fuzzy logic. The other part is a neural network. Now, as a neural network, this was developed way back in 1950s to make a replica of a human brain towards the artificial intelligence. So, an artificial neural network is an attempt to take the networks of the neurons, just like a mimic of a human brain, so that the computer can able to learn, train, and make a decisions in a human way. So this is what the neural network indicates. So in a neural network is a network of a artificial neuron, and this is based on the biological network, or it is inspired by the biological network of neurons, and that use the mathematical model of as informations processing, and thereby it will try to produce a complex computations that a human find it difficult to solve it at an instant. The next is evolutionary computations. Now evolutionary computation, it is basically the family of optimization algorithms, and this is basically inspired by the biological evolutions such as genetic algorithms. And as you know that in the genetic algorithms we consider the terms like the genes, and based on the genes the selection procedures we try to consider. So that's why in the genetic algorithms the search based algorithm is used to find the best selections of the group of genes to decide the family. So genetic algorithm is the subset of a large branch of a computations, or we call it as a evolutionary computations. If you look across the classes of evolutionary computations, you will find that swarm intelligence, ant colony optimizations, artificial bee colony optimizations, these are nothing but a biological or a evolutionary computational optimization tools. So now these three combine together and it produces a soft computing. So soft computing is an approach to computing a parallel remarkable ability of a human minds, so that it can able to produce a desired or a desired output based on the uncertainty and imprecisions. So soft computing is a flexible approach, or we can put it as it is a tolerant to the imprecisions. Now let us look across the soft computing approach. The soft computing approach towards the complex systems, it will try to take the consider the complex system and apply the approximations and apply the mathematical and analytical approach, so that it can able to produce the results. So soft computing is basically deals with the imprecisions, uncertainty, partial truth, and approximations, and thereby it can able to achieve a tractability, robustness, and low solutions cost. So this is what is a very important. It will be it deals with the imprecision, uncertainty, partial truth, and approximations. So based on this soft computing approach will produce a robust tractability and a low certainty cost. So if you try to see the soft computing approach, the decisions that it takes based on the imprecise value. The second part is the inference of the previous solutions experienced. So whatever the decision it takes, that decision will be based on the previous results, and the previous results and the present results closeness or the inference we take into consideration. Expertise in the area. So based on the previous results and the outcome, it will take into consideration the current, and it will try to look across the decisions, whether that decision based on the expertise approach is is it a closer value, and improvise that particular results as compared to the previous, and it adapt to the changing environments. That means soft computing is able to handle the different conditions, so that it will able to produce the results with the improvised conditions based on the previous values. Learn to do better, because it will learn, and thereby it will try to improvise. So learn to do better. Social behavior of a collective intelligence. So soft computing approach is used for the applications where we don't adopt for a very precise value, rather or a critical systems. Rather, we try to look for a solutions that can able to meet the needs. So that's why if you look across the social behavioral approach, human intelligence, or the psychological trend, or the psychological concepts, all these areas are the social issues. All these areas we can apply the soft computing approach. So that's why in the soft computing approach, these 6 different approaches is being put across to make the intelligent control strategies in a more effective manners. So among these 6 approach, if you try to see the first 2 characterize, that is taking a decision and inference, it is based on the fuzzy logic approach, because the decision approach and the inference approach is basically done in the fuzzy logic. The second, third and fourth, second, third and fourth is also a part. Second is also a part of a next condition, that is a neural network. So second, third and fourth is being led to the neural network, because in the inference conditions we try to take the selective approach. Expertise means we try to look for the best fitting, and the adapt to change means that best fitting will be looking into the conditions which that can able to fit to the improvised condition of the previous. That means the previous will be inferior as compared to the present. So it will try to look for the best condition. Let's take an example here in the novel corona, where every day you will find that several data sets are appearing. So from these data set, the scholars try to look across and what are the best feasible conditions or best feasible reason this particular virus try to infer to the different conditions of the human beings. So that's why this second, third and fourth falls under the neural network. And now fourth, fifth and sixth. is used for the evolution computations. The evolution computations is basically we can take to look for the improvement, let's adapt to the changing environment, learn to do better, and social environment. Because if you try to see across in this particular case, there is an improvement based on the previous conditions. So that's why this fourth, fifth, and sixth is considered under the evolutionary algorithms. Second, third, and fourth, because as compared to the first and two, though we give the inputs, the same input, the output, same input and output. If we try to give to the neural network with improvised condition, it will try to do the computation in a best way. Like for example, deep learning. Deep learning falls under the class of a 2, 3, 4. And 4, 5, 6 is adapt to the changing environment, means it is again look for the previous environment and the current environment, and that environment should find a results that should be improvised. Otherwise, the genetic algorithm does not fit. In the third, if you try to see the expertise areas, the expertise areas is basically the best method of computation. That's why when we take the consideration of a database of a COVID-19, the expertise area in the area we have to apply for the we have to apply for the deep learning to find the best results. Now coming to the knowledge series applications, you will find the knowledge series applications as a wide application: fuzzy logic, machine learning, neural network, biological inspired computational model, support vector machines, meta heuristic, swarm intelligence, new optimization technique, expert system, deep learning algorithms, and artificial intelligence. Now if you try to see across the fuzzy logic, it is an approach to a computational based on the degree of truth rather than the true or false. That is a fuzzy logic. So that's why it is based on the imprecise condition or a closeness value. So we say the degree of a truth or a membership functions values rather than telling true or false. For a 1 and 0, instead of saying, we can say closeness to 1 or closeness to 0. The machine learning is a subset of the artificial intelligence. So machine learning is basically based on the testing and training and testing methods. Neural network is a for connecting the computing systems inspired by a biological neural network. So in the neural network, we have a set of nodes or a biological neural nodes, and these new nodes are interconnected, and in the same way in the soft computing we use the neural network concept for doing the computations. Then comes the biological inspired computing model is nothing but a genetic algorithm and evolutionary computations. The genetic algorithm is a meta-heuristic inspired by the process of a neural selections, where we apply the multiple inputs and try to find the desired output. And the genetic algorithm, it is in the evolutionary computation, it is a family of algorithms for a global optimizations by a biological evolutions. As I shared earlier, that in the case of evolutionary computations, we apply the ant colony optimization, practical swarm intelligence, artificial bee colony optimization. So all these things is a class of evolutionary computations. Support vector machines, particular machines, basically it is used for the supervised learning in the case of a machine learning. So this is one technique used for applying the machine learning algorithms. Now the next is a meta-heuristic. Meta-heuristic is the higher level of a heuristic approach to find the best optimizations conditions. Swarm intelligence, it is basically a biologically inspired artificial intelligence for applying the best optimizations. A new optimization technique I have already shared, ant colony optimization. It is based on the computational problem for a good path with respect to the ant. You can know that how the ant moves. Partial optimizations, it is based on the computational methods to optimize the problem by iterative condition. That is a practical optimizations. Next we go with the expert systems. Expert system is a software which basically use the database of expert knowledge for taking appropriate decisions. So that is known as expert systems. Deep learning algorithms, it is basically broader class of families of machine learning algorithms, methods, and basically is used for the specific applications. And finally, artificial intelligence. Artificial intelligence is the intelligence demonstrated by the machines, and it combats to the natural intelligence by living beings or a human or other animals. Because in the artificial intelligence, we try to do a replica of the human conditions, how the human behave in the similar way we apply the intelligence. So these are nothing but the different applications related to the soft computings. So we have come to the end of this particular segment, and here we have discussed on the different soft computing about the soft computing, its soft computing segments, and followed by we have discussed what are the different components of the soft computing. Then we discussed the different applications of the soft computings, and finally we try to come to the conclusions of the soft computing by summarizing as it is. Soft computing is basically a traditional computing approach that is based on the imprecise or based on the assumptions to deal with the approximate model, and thereby it gives a real solutions just like a real life problem. And soft computing is basically used for the approximate calculations, as I told, that to provide imprecise but usable solutions to complex computational problem. And it is based on the technique of fuzzy logic, genetic algorithm, artificial neural network. Of course, we can put a machine learning and expert systems. And this approach is basically used for the consumer applications, in the food preparations applications, in the industries, in the games, in the recognitions systems, and many more. So for finally, before I conclude, let me say that the tolerance of a soft computings allow a research to this particular field, and hence this particular soft computing approach is there improving day by day in the field of artificial intelligence. Thank you.